My name is Katrine Raundrup, and I'm from Greenland Institute of Natural Resources in Nuuk, as Hannele mentioned. And I'll give a presentation about the long-term monitoring that we do at Greenland ecosystem monitoring sites in Greenland. And I'll come back to that, and I'll, of course, explain everything to you. I'll give a short introduction to the stations involved in the network, and that is Sakenberg Research Station, the Arctic Station at Disco Island, and then at Kobbefjord, where the Greenland Institute of Natural Resources have a field site. First of all, I'd like to kind of draw your attention to the Interact webpage, where you can find all sorts of information about the stations involved. And this is just a screen dump from just displaying the Greenland stations within the network, and there are 9 of those. And I've listed them all on the right-hand side of the screen, and also mentioned which of them give transnational access support, remote access, and virtual access support. And the 3 stations that I'm going to mention for you today will be those highlighted here. The Arctic Station, which is in the middle central West Greenland, the Greenland Institute of Natural Resources close to Nuuk, or in Nuuk, and then Sakenberg Research Station in northeast Greenland. And just very shortly, the 3 stations, they cover 3 different climatic zones within Greenland or within the Arctic. The Sakenberg Research Station in high Arctic northeast Greenland, the Kobbefjord site and the Greenland Institute of Natural Resources in low Arctic, and then Arctic Station in central West Greenland, which is on the border between high and low Arctic. The information you can see in this table is also from the webpage, and you can find all kinds of different information on the Interact GIS or in the field site catalog, field station catalog. The 3 stations, they also differ with, for example, permafrost. As in Sakenberg, they have continuous permafrost. In low Arctic Greenland, we have none, and then at Arctic Station, it's kind of on the border, so they have discontinuous permafrost. Arctic Station in central West Greenland, it opened more than 100 years ago, so they have a long record of data collection. The Sakenberg Research Station opened in 1995, and the Greenland Institute of Natural Resources in Nuuk also opened in 1995. There's almost a similar capacity for people to be accommodated at the different stations, and you can see the numbers here. Within Interact 2, we had between approximately 10 projects at each of the stations, but the number of projects doesn't actually say a lot about the amount of days actually spent at the station. But I have included that, but that's just to give you an overview that we do offer TA and remote access at these stations, so you're more than welcome to come join us when all this Corona is done with. This presentation will give you an introduction to the network called Greenland Ecosystem Monitoring, which is an integrated monitoring and long-term research program on ecosystem dynamics and climate change effects and feedbacks in Greenland. So essentially, we look at the effects of climate change in Greenland. And it's not something that just one institution is involved in. It's a collaboration between institutions in Greenland, the Greenland Institute of Natural Resources, ASIAC Greenland Survey, and then institutions in Denmark, University of Copenhagen, Aarhus University, the Technical University of Denmark, and GEOS, which is the Danish and the Geological Survey of Denmark and Greenland. So it's not something that is done on its own. It's a collaboration between a lot of different institutions in both Denmark and Greenland. We have an annual budget of approximately 30 million Danish kroner, corresponding to approximately 4 million euros. So it's not something that is, it's not money that are easily found, and it is really expensive to run these long-term monitoring programs. We are mainly funded by DANSIA, which is one of these acronyms that you can actually pronounce, and it's an abbreviation of the Danish Cooperation for Environment in the Arctic, and it's mainly funded by 2 ministries in Denmark. Then the Greenland government also contributes quite a lot to the financial wise, and then of course the institutes involved have their own financial contribution. For that sum of money, which is quite a lot, we are able to work within a quite big realm within the Arctic. We look at a lot of different parameters and measure approximately 2,000 parameters, covering everything from glaciers to the near coastal areas. So we do not work on the inland ice, for example, and we do not work in the open ocean, but we cover everything in between. And this diagram shows you the fact that we actually work from glaciers connected to the ice cap or standalone glaciers, all the way through freshwater and land, energy fluxes, vegetation, mammals, birds, to the coastal areas where we look at production in coastal waters as well. We do that within 5 basis programs, and they're all listed here, and it looks a bit confusing, but I'll read through almost all of it. So the 5 programs cover everything from climate to glacial basis. It's a climate basis program, it's a geo basis program, a bio basis program, marine basis program, and a glacial basis program. So we study everything from collecting data on climate, that is climate and hydrology parameters. We look at abiotic parameters within the soil and energy fluxes and stuff like that. We look at key species and processes within the plant and animal populations, with both on land and in freshwater. And of course, we also study everything you can imagine in the marine environment, covering everything from abiotic parameters to biotic, from phytoplankton up to humpback whales. And then we do also look at glaciers and look at, for example, mass balance of glaciers. And again, that is not the inland ice, it's only glaciers. All of the data that we collect and the data that we are paid for by the Dansea Foundations to collect are actually available for free on our homepage. There's a link to the homepage here, but the final slide will also give you kind of all the sum up of good ways to find data and papers and stuff like that. But we have a database where we collect all the data you can imagine, and all the data that we collect that are funded by Dansea. As I said, we collect more than 2,000 different parameters, and we also submit data to international repositories. But in these days, when we have the COVID situation and people are perhaps not able to go to the Arctic to collect their own data, you should definitely take a look at the GEM database, because the data is just there for you to use. Of course, you have to register, but then you can use the data as you like, and including relevant corroborators if you plan on doing any papers based on the data. But it's information about all that is in the database homepage. And I'll give you a few examples of the type of data that we collect. Of course, we do collect temperature data. This plot is covering data from 1996, when the GEM program was started, and up until 2018. And it's a mean annual air temperature at the 3 different sites, at Sagenberg, at Disco, and in Koppefjord. So you can actually just find the data directly in the database. There's also information about, this is a plot of snow depth at the 3 different sites, with the measurements from 2018, and then the average and max and mean snow depth, just to give you an idea of the differences between the sites. There's also information about the maximum thaw depth of the active layer. And again, this is data from 1996 and up to 2018. This plot is from Sagenberg, as for example in Nuuk we don't have permafrost and we don't do measurements of active layers, but this is a plot from Sagenberg. We also look at, for example, humpback whales. We collect data on appearance and the number of humpback whales. We do that here close to Nuuk. And we also, for example, look at different passerine birds. But again, we do a lot of different measurements, and it's almost all up to your imagination to figure out how you want to work with the data. Aside from kind of the count data that we do and the normal collection of data, we also have data in the form of photographs, as we do both automatic photographs of different areas within each of the 3 sites. We also have, for example, this is a photo of a tiny little glacier in Kobbefjord, where we do 1 annual photograph of that specific glacier. But it's actually quite interesting because we started taking these photographs in 2010, and then some years ago we discovered there's this Danish photographer called Heinrich Rink. He was a geographer and geologist, and he lived in Greenland from 1848 to 1868. And actually he went to Kobbefjord and he took photos from different locations or different sites in Kobbefjord. And they were later hand-colored, and then you can actually see that it's completely the same glacier as we, by chance, started taking photographs of in 2010. So in 2018, we actually had a master student who went out in his spare time and actually found the exact plot where Heinrich Rink took his photograph. So we can actually have these 2 points in time where we had photographs of the exact same glacier. But there's quite a lot. There's more, approximately 150 years between those photos. And still, even though we have the annual photos, the ones in top from 2010 up until 2018, they are not all depicted here, but there's still quite a lot of uncertainty as to what happened between 2010. So we actually did a survey both here in Nuuk and using Facebook to get in connection with people who used to live in Nuuk. So people have actually contributed with photographs. This is a photo from 1990, and we've also got a few photos from the 1970s where people have kind of, you know, by chance actually taking photos of the same glacier. So we're able to kind of connect all the dots going back in time and looking at when the changes on the glaciers started. It's not something that is uncommon. I know many stations within the Alpine region have similar photograph series of specific glaciers in their areas, but it was actually something that just happened by chance here in Nuuk, because we had no idea that Heinrich Rink visited the place in 1867. So this is just another way of looking at the current data and then going back in time to see what actually happened before today. I'm also going to talk a bit about the benefits of long-term monitoring, because you can say, well, normally people, they get funded for a few years and then they do their studies and have data for 2 or 3 years. But one of the benefits of long-term monitoring is that you can actually look at, for example, missing data points in your data series, or if there are extreme events that cause something specific, you can actually have a way of kind of checking up how the ecosystem functions afterwards or during some of these data gaps or extreme events. So the top figure here, I'm gonna give you an example of something that occurred both in Kobbefjord and another one where that happened at Sagenberg. This is a plot from collecting data from 1996 until 2018, and then the plots or the data points from 2019 actually indicated here on the right hand side of the figure. But it's a mean day of 50% of flowering. The yellow bar or the yellow lines are from Sagenberg and the blue ones are from Kobbefjord, and they are showing the 50% flowering dates for 2 species of willow, one that is found in Kobbefjord, greyleaf willow, and then Arctic willow in Sagenberg. And as you might be able to tell, there's something happening in Kobbefjord within this red box. There's 3 years where we have no data. And it's not because we were lazy for these 3 years, so we didn't go out and collect data, but I'll give you the story to that afterwards. There's also something happening in 2018 in Sagenberg, where the mean day of 50% of flowering was really late. It was in late July. So something was happening in 2018 in Sagenberg. Of course, the benefits of long-term monitoring will also give you a trend in, for example, muskox density, as the lower figure indicates. So you can actually see that something is going on in the mid-2000 or 2006 or 7, where you can find a lot of muskox. It's muskox density in numbers per square kilometers from the years 1996 until 2018. So long-term monitoring is really, really important if you want to know what's happening kind of with the study species that you're actually looking at. And then of course, the long-term monitoring can also always be kind of the background of the research projects that are done at the site. Because if you're just visiting for 1 or 2 years, you will also get kind of points in time, but then you can always kind of connect those points in time to the background information based on the long-term monitoring. But let's start with the upper figure. This 3-year period where something was definitely going on in Kobbefjord. What was going on? Yes, for a couple of years we had a visitor, not a very nice visitor in the area. It was the larvae of this moth called the great gray dart, and the adults, they normally swarm in late summer. They lay eggs, and then the eggs, they survive underneath the snow in patches of moss, for example, and then in early spring they emerge as larvae. And these larvae, they are able to kind of completely eat off all the greens you can imagine within an area. On the right hand side, I was supposed to show you a little video, but before Hannele and I tested it, and I'm sorry, it doesn't work. Oh, sorry. But at least it shows you one of these caterpillar moths. It's, well, they're called Erois occulta in Latin, and it's eating off crowberry blossoms. But normally they eat a lot of willow, and on the lower panels with the photos, this is a shot from July 2011, where it's almost completely brown or grayish. And it's not due to a late spring or a late summer, for example, but it's actually due to the fact that these larvae had completely defoliated the area that is normally covered by really fresh and bright green willow, amongst others. The photo on the right-hand side is from 2012, and it's also from July, showing what it looks kind of in, I would say, normal years when it's green and bright. The little red square is it's one of our experimental plots where we do CO2 flux measurements, and the following couple of slides will be results from that specific area. Because we have an ITEX set up on one of the slopes in Kobbefjord, where we have these open-top chambers, the ITEX hexagons. We have plots where we shade the vegetation, and then we of course have controls. And in normal, I would say normal years, the heath, the low kind of shrub heath, it acts as a CO2 sink. That is, it takes up loads more CO2 than is released back into the system. But when we have visitors like Erois occulta, the situation looks quite a bit different. This plot, it is a bit difficult to kind of maybe interpret if you're not used to looking at these. It's a measure of CO2 flux. So when there's a positive flux, there's more CO2 released to the system or to the atmosphere. And when there's a negative flux, then there's CO2 uptake within the plants and in the soil. And in 2010, we actually thought we had a major outbreak of these larvae. It turned out to be kind of just a stepping stone for the larvae, because then in 2011, that's when we had the major outbreak. And maybe you can see that in some part of the year, we actually had more CO2 released from the system than what was taking up. So at least we can say that in larvae year, the release and uptake were almost equal, and actually the heath worked as a source of CO2 instead of being a sink of CO2. But then something happened in the years following 2011 when we had the outbreak, because you can see that in the following years, the uptake of CO2 was actually increased quite a bit compared to the years, both during the larvae attack years and prior to that. And that's also one of the major advantages of actually being able to go back into our data series and look at photos, because we take weekly photos of our plots. We can actually see that this is the same plot photographed there. Well, there are weekly photographs of each of the plots, but this is from one specific day of year in the different years. And you can see in 2010, when we thought we had the major outbreak of larvae, there was actually no flowering developed on this willow. But in 2011, when we had the major outbreak, the plants actually looked rather dead, and we were uncertain if they were able to survive 2 years in a row with a larvae attack. But then in the following year, the plant actually seemed to respond very positively, having been set back for 2 years. So in 2012, the willow actually grew quite a bit, but it did not produce any flowers. It did so in the following years, 2013, 14, and 15, and up until 2019. I've not included those photos, but there has been an immense amount of growth in all the individual willows on that slope where we do the measurements, the CO2 flux measurements, and also an enormous increase in amounts of flowers in the individual plants. So actually the willow responded quite positively on the setback it had endured within the larvae attack. And actually it shows how resilient Arctic vegetation actually is to endure these kind of extreme events. From one event to another, I'm moving to Sagenberg this time, where we in 2018, this is a photo from late June 2018, where the snow and ice stayed extremely long. And as you might recall from the figure I showed you earlier, with the mean day of year for 50% of flowering, in Sagenberg, which is the yellow line up here, in 2018, the mean flowering date was in late July. And of course, that has something to do with a lot of different things, and there's a lot of different repercussions followed by that. If we start by the top, in the top hand bar, this is the snow cover in percentage in mid-June, which is the red one. These are, I have to say, it's from 1996 going on to 2018, and this is just a percentage out on the y-axis. So it's a snow cover in mid-June in all of the years from 1996 to 2018, and then the blue line shows the snow cover in end of July. And even in the end of July, the snow cover percentage in the Sagenberg area was almost 50%. And of course that influenced the flowering dates for dryas, which is the flower here on the right hand side. That in most of the plots, they didn't flower at all, or they flowered really, really late, in late July, early August. Once you have flowers that need pollinators, you also have to look at the time of year when the flying insects are actually around. And as this bar here in the middle is the timing of flying insects. And again, all of the plots are from 1996 to 2018. And you can see definitely that at least in some of the plots, the flowering or the timing of the flying insects were really, really late in 2018. Which could indicate that a lot of the flowers they were supposed to flower, to pollinate, were actually not pollinated, and thus the seed setting in that year was really low. the very late snow cover melt, or the late snow melt in 2018 also influenced the waders. This is just an example of one of the waders in 2018. So this plot is a plot of the density of waders per square kilometers. So in 2018, there was hardly any waders in the area, because they arrived and were not able to kind of make a nest, and then they left again. It also influenced the number of muskox calf per 100 females, which is the lower bar. So in 2018, there were hardly any muskox calf. And again, for the density, since the density of waders were that low, it also meant that in 2018, there were hardly any young that fledged. So in 2018 was a really, really poor year, both for example, seed settlings in flowers, for youngs of waders and for youngs of muskox calves. But having a long-term monitoring program will actually give us the opportunity to study the long-term effects, and we are kind of doing that in the coming years, of course. So I've given you a few examples of the data that we are collecting and a few stories about what has actually been published later on based on our long-term monitoring. You can find annual reports, you can find annual report cards, which have been produced since 2016. And I must say the one from 2019, it's only a draft yet, but it will be published very soon. You can find special issues, one that was published in 2008, for example, in Advances in Ecological Research, which mainly focuses on data collected in Sagenberg. Then there's a special issue from Ambio in 2017, which covers data collected in Sagenberg and in Nuuk. There's hundreds of peer-reviewed papers and different theses from bachelor to PhD theses. And you can find everything on the GEM homepage. And this is the top link. And if you're keen on following kind of the daily life of the different programs, you can use our Twitter accounts to kind of connect to those. They're all listed here. And yeah, please follow us and give comments when we post stories. And if you have any questions, you can contact me. I live in Nuuk, and you can find my address and information here. Thank you so much.
Thank you, Katrine. A really, really interesting, wonderful presentation. Now we have time for a couple of questions or comments. If anyone wants to ask something, you can type your question into chat, or you can just unmute your microphone and make a question to Katrine. I just want to comment, Katrine, that I was really impressed by the extent of the monitoring that you are doing, the GEM program, and I think you were really able to demonstrate with these examples the importance of the long-term monitoring and the large variety of ways that you can utilize the data that you are collecting.
Exactly. And since all the data is actually freely available, I really encourage people who are maybe still stuck at home or not able to visit either Arctic or Alpine research stations this summer, that they can just tap into our database and think about projects where you can actually compare high Arctic, low Arctic, and data from a station kind of in between, compare data and do research on that.
Absolutely. Is there any questions? Antoine wants to ask something. Please go ahead, and Outi after that.
Okay. Thank you very much, Katrine. It was very interesting. Actually, I'm starting to analyze the flowering data that we can find in GEM. So I think you survey many different species from Dria, Saxifraga, Salix, etc. in Sagenberg as well as in Nuuk. And we had this very basic idea with Niels Martin Schmidt and Thomas Rosling. So I am a postdoctoral researcher in the Thomas Rosling group. And since the plan for this summer is not so easy, we decided to maybe analyze those data. And I just have a quick question. If I recap correctly, you're starting monitoring the flowering count in Zook and Zackenberg around 1996, something like that. That's correct?
Yeah, in Zackenberg, they started their monitoring in 1996. In Nuuk, we had the full first season in 2008. And actually at the Arctic Station, the bio part of the monitoring program is not funded. But so there's actually no data from that. But at Zackenberg and Nuuk, we have data, comparable data from 2008, and Zackenberg have data from 1996.
Okay, and those data were never be already analyzed together, like?
No, not to my knowledge.
Not to your knowledge. Okay.
No.
Excellent. That it's promising for.
Yeah.
Idea. Okay,
yeah.
Excellent.
Okay, and then Outi wanted to ask something, please, quickly. We can't hear you, Outi, now. I'm sorry.
Otherwise, if we are running late, Hanneli, then she can just contact me.
Yeah, okay.
People are more than welcome.
That'd be okay, Outi. Okay, perfect. Then thank you so much once more, Katrine.